On November 12, 2003, that is on Sunday, early morning on Diwali, due to a landslide, a portion of the tunnel collapsed in Uttarkashi, which is a district in Uttarakhand. The name of this tunnel is Silkyara Tunnel. It is part of the ambitious Char Dham highway project. Char Dham, as you know, is 4 Sanatani Hindu religious sites located in the Garhwal Himalayas of Uttarakhand. These places are Kedarnath, Badrinath, Gangotri and Yamunotri. Government of India has undertaken a major infrastructure initiative to improve connectivity between these 4 Sanatani Hindu religious sites by constructing 900 km long all-weather national highway roads, which will connect the whole of Uttarakhand state. The Char Dham project officially began on December 27, 2016. The total estimated cost of the Char Dham project is around 12,000 crore, that is approximately $1.5 billion. The project is being jointly funded by the Government of India and the World Bank. The project is expected to be completed by 2025. As you can see in this map, the Silkyara Tunnel is located on the Yamunotri National Highway number 134, between Silkyara and Barkot in the Uttarkashi district. The Silkyara Tunnel is 4.5 km long and is expected to reduce travel time from Dharasu to Yamunotri by about an hour. As you can see through this map, the tunnel is being built here. If you travel by road from Dharasu for some 20 km to the north, you will encounter a challenging section where a U-turn is necessary. This stretch of road, designated as National Highway number 134, winds through a mountainous region, making the travel time considerably long. The entire length of this winding highway is estimated to be around 25 to 30 kilometers. Due to the elevated land and geographical terrain, covering this distance takes a lot of time, which includes road blockage and traffic jams. To reduce the travel time and distance, the Government of India has proposed the construction of a 4.5 km long tunnel connecting 2 points from here to here, with the potential to reduce travel time by nearly an hour. Now, the land elevation near Uttarkashi district varies greatly depending on the specific location. However, the average elevation of the district is around 1165 meters. The town of Uttarkashi itself is situated at an altitude of 1158 meters. Here is Yamunotri, the source of Yamuna river. The land elevation is around 3293 meters. Gangotri is here. The land elevation is around 4191 meters. Then Gomukh, source of the Ganga river. The land elevation is around 3892 meters. As you can see, the land elevation in Uttarkashi district ranges from quite low to very high. This is because the district is located in the foothills of the Himalayas, which are some of the tallest mountains in the world. Now, as I mentioned, the tunnel collapsed at approximately morning 5:30 am on November 12, 2023. A section of the Silkyara Tunnel, that is around 160 to 260 meter section of the tunnel from the Silkyara end, collapsed. 41 construction workers were trapped inside. Let me also remind you that the drilling of the Silkyara Tunnel is not fully complete. The tunnel was approximately 25% complete. The tunnel collapsed within the first 160 to 260 meters of the tunnel from the Silkyara end. As per the news report, it is said that on November 12th, there was a landslide in the Uttarkashi district of the Himalayas, and this is what led to a tunnel collapse. If you see, that is an obvious as well as a very common general reason, because the Himalayan region is known for its geologically unstable terrain. And not just the Himalayan region, any mountainous region is considered geologically unstable. Such areas consist of brittle rocks and a complex geological structure, making them prone to landslides and rockfalls. Now, it's not as if this is the first infrastructure that is being built in such a sensitive geological region. There are many places in the world where man has constructed even more complicated infrastructure. So, what must have gone wrong here that led to such an incident? The first factor, as I mentioned, is that this region is geologically unstable. This is also a very common and general reason. The second factor could be improper geological assessment. Maybe the geological assessment conducted for the tunnel construction was not comprehensive enough to fully identify and predict the potential risks associated with such massive construction. The third factor could be regarding the way blasting techniques were being conducted during tunnel excavation. Several blasting techniques can be employed to reduce the risk of landslides and tunnel collapses during tunnel construction. Because blasting produces vibration, and vibration, as you know, can lead to breakdown of materials at a molecular level, depending on the intensity of the vibrations. The fourth factor could be lack of proper support system for keeping the tunnel intact. Some common support system for tunnels include shotcrete lining and rock bolts. Spraying shotcrete onto tunnel walls helps to stabilize loose rocks and prevent rock falls. It reinforces the tunnel lining and provides additional support. Rock bolts are used to reinforce the surrounding rock mass and prevent collapses. Rock bolts are typically anchored into the rock to provide structural support. So, depending on the geological conditions, tunnel depth, and construction methods, specific support systems are used for keeping the tunnel intact. And the fifth factor could be a failure to address warning signs. Maybe some indications such as minor rock falls or cracks in the tunnel walls were missed or ignored. And maybe these warning signs were not properly addressed, and that could have led to a collapse. So these are the 5 factors, or maybe a combination of these factors must have led to the collapse of the Silkyara Tunnel. Now see, these reasons mentioned are possibilities of occurrence. It doesn't mean that it's a deliberate act. Yes, humans make mistakes, but these mistakes are later analyzed, and the tag of error is assigned only after careful examination. There are many things related to nature that humans cannot fully understand, even with thorough training, technology and attention. The possibility of errors in such matters is quite high. So, know these reasons strictly for the perspective of an examination, and don't form an opinion that says everything can be controlled by humans. As we know, 41 workers were trapped in this tunnel for 17 days. You can imagine the situation, the darkness, fear of uncertainty, claustrophobia, and more importantly, the fear of being buried alive. All these thoughts can easily break a person's mind and his determination. Now the question is how these workers got their survival essential supplies for 17 days. Initially, the workers were given high energy snacks such as dry fruits, nuts, and puffed rice through a small pipeline that was drilled into the tunnel. These snacks provided them with immediate energy and essential nutrients. Even oxygen was pumped in through the same narrow steel pipeline. As the rescue operation progressed, a larger pipeline was installed, supplying of larger quantity of food such as cooked meals, rice, lentils, soybeans and peas are among the items that were sent through the pipeline. These workers were given food rations at regular intervals. In fact, the ability to provide food to the trapped workers was a significant achievement in the entire rescue operation. And the final question is, how were these workers rescued? How were they extracted from the collapsed tunnel? First of all, the entire process was a complex and challenging operation. In the beginning, the National Disaster Management Authorities used a vertical drilling machine and drilled up to 47 meters. The drilling machine was an American auger machine that was flown down from Indore for drilling and installing steel pipes of 800 and 900 millimeter diameter for making a passage to rescue the workers. However, the drilling machine broke down because the blades of the auger machine got stuck in rubble. The authorities couldn't continue drilling further because the stuck blades of drilling machine could cause vibrations in the tunnel if any deliberate force was applied. The NDRF authorities then considered an alternative approach, and what is that? They decided to use a rat hole mining to navigate the remaining distance. Now, what is rat hole mining? Rat hole mining is also known as rat mining. It is a dangerous and illegal method of coal extraction that is commonly seen in the Meghalaya region of northeast India. In this method, narrow vertical shafts are dug into the ground just like rat holes, from which coal is extracted manually. These shafts are typically 3 to 4 feet in diameter, making the workers to get in and out only by crawling. This method of mining has been criticized mainly on the grounds of human safety and environmental damage. This practice has led to numerous accidents, deaths, and environmental degradation. In fact, in 2014, the National Green Tribunal of India banned rat hole mining, recognizing its dangers and illegality. However, the practice continues to exist despite the ban, and because of that, these 41 workers were also rescued by rat hole miners. This is an example where a traditional skill with local knowledge which has been banned by government institution turns out to be effective in saving lives. And this also tells us that something hazardous can turn out to be beneficial in emergency situations. So what happened was, after the auger machine failed to clear the remaining 10 meters of debris, the rat hole miners stepped in. They crawled into the narrow 800-meter diameter tunnel and manually dug the remaining obstacle, continuously working for 26 hours. These local rat miners were also familiar with the local geology and the type of rock formation this area has. They were able to anticipate potential difficulties and adjust their techniques accordingly, saving valuable time and resources. And certainly it was a team effort where rat hole miners collaborated with different rescue teams, including engineers, geologists, and medical staff. The miners' readiness and willingness to work together and cooperate with educated scientists and experts, and the mutual acceptance and acknowledgement by these knowledgeable individuals to seek the help of rat miners played a significant role in the success of this rescue operation. In the end, what we need to understand is that any kind of development, progress, value, and growth comes with a cost. In many cases, the outcome, the consequences, or the cost can always turn out to be uncertain. Life in mountainous regions is challenging, with treacherous and unpredictable paths. In this context, the need for development is quite obvious. However, any form of development comes with a cost, and that cost can arise from any source, in any manner, at any time, which we may not always be aware of. The same holds for the Himalayan region. Here, any kind of deep study or any kind of deep research about the land is not enough. Nature has its principles, and the depth of those principles is perhaps something that humanity can never fully comprehend. I hope you found this video informative. Thank you for watching it.